Hello everyone and welcome to celebrate with us the International Year of Light. Over the past century, physicists around the globe have made great advances in the science and technology of light. We also would like to recognize this event and therefore present to your attention one of the key experiments in your optics teaching program, the Michelson interferometer. There are several reasons why the Michelson interferometer is a must-have in every physics curricula. In the lab courses, this experiment is used for the measurements of wavelengths by interference. It is also a standard tool for the high-precision length measurements in engineering applications. It also can be used for the determination of the refraction index of gases, fluids, and solids. Did you know that the Michelson experiment was a ground basis for the Albert Einstein development of special theory of relativity in 1905? Now let's talk about the experiment itself. Here you can see PHYWE experimental setup, having an optical bench and an interferometer, having all optical components integrated in a single piece. As a light source, we have a laser with a wavelength of 532 nanometers. We have a lens and a screen to capture the interference pattern. The main background concept of the experiment is as follows. The laser beam travels to the beam splitter of the interferometer. The beam is divided into two separate beams with equal intensity. Next, both beams are reflected back by a mirror and superimpose. Due to this superposition, waves interfere with each other. This interference can be observed on the screen. Next, by moving one of the mirrors and analyzing the variation pattern, we can determine several quantities. For example, the wavelength of the laser beam. The advantage of such experimental setup is that the adjustment of single optical components is not necessary. This makes it a perfect experiment for the beginner lab courses and for students in physics as a minor subject. For the advanced physics laboratory courses, it is better to use an experimental setup where all single optical components can be adjusted individually. Such Michelson interferometer will enable you to learn how to handle optical components. For this purpose, PHYWE offers to you the Michelson interferometer experiment on the optical baseplate. We hope you enjoy our video and we could raise your interest to the Michelson experiment. If you have any questions, please do not hesitate to contact us. Thank you so much for your attention and bye-bye.